Well, hey guys, good evening. It's Ted Tagami with Magnitude.io. And you guys have been very curious about getting that information from your rocket launch and your high altitude balloons, for those of you that put the balloons up. And so, in this really brief tutorial, I'm going to show you actually how to do that. For you, those of you that to assemble the kit, you'll be looking at your CanSat unit like this, little micro SD card slot right here. For those with the science unit, same thing, micro SD slot right there. That's storing all your data from your flight. I think we went over this in your class, but as a refresher, you just take your little micro SD cards out like this. Uh, and you're going to go ahead and put it in the larger adapter, and you're going to put that right into your TC. Voila, that should slide right in. That's going to allow you to read all the text files that are on your card. So what does this thing look like? When you open it up, you'll have a number of text files. The one that we're going to want uh, is this text file that looks like this. You'll have temperature and humidity, you can see here, as well as some other data, acceleration, latitude, longitude, bunch of different numbers with really just looks like noise on each row. This is called a comma delimited file. It's a text file, but sometimes they're called CSV for comma separated value. And of course, you can see commas in all your data here. Sometimes they use tabs to separate data or some other separator, but this is comma separated data. So we're going to take this and we're going to actually import it into Excel. And that's really easy to do. Let me switch over to Excel, go to a full size here. And in Excel, it's real straightforward. Let's see, what did I just do? We're going to select data, get external data, and import the text file. We'll look for the text file from our, in this case I have it in my downloads. And you're going to be given some choices. There's 3 steps in your import wizard. We're going to select delimited, and this is what your data currently looks like. We just looked at that a second ago. And then select next. Then you're going to see these delimiters that are set up. The data still looks kind of ugly. We're going to go ahead and click comma separated, and look what happens. Those commas have just separated all your information into nice, neat little columns. Doesn't that look pretty? And that's all we really need to do. The next step is general. We can leave that alone, and we can finish. It's going to ask if we'd like to import this in the cell A1. Click OK, and your data will now be populated. Let's go ahead and highlight our fields so we know what they are. You notice it looks like here that our lat long and altitude speed information didn't lock in the beginning part of getting the CanSat set up. So I'm just going to go ahead and remove that information. Let's see, it looks like about here. Look, we have a little noise in the data as well. Might have rebooted briefly. I'm going to go ahead and just edit and delete. Make our data a little clearer. So now we have information for our temperature during our flight profile, basically from getting your CanSat powered up through the end of the flight recovery, as well as humidity, the amount of moisture in the air. The air pressure, of course, air pressure will help us to determine the altitude, as we learned in class. The temperature as it's being read by your pressure sensor, which in some instances will be slightly off. You have acceleration across your 3 axes. We'll look at that, as well as the magnetometer and the latitude and longitude. Now you can take that lat and long and actually plot it on a map. That's pretty fun to do. But for now, we're just going to show you how to get this basic data up and running. Cool, we got the text file from your CanSat. We've imported it into Excel. Let's look at some stuff. I'm going to highlight column A and B and select charts, and go ahead and select a line chart, simple line chart for now. And we see a relationship forming here. Now, I am not going to format in this brief video because it's really ugly, but I think you're going to see the data is actually quite beautiful. And so the blue plot line here is temperature over time, and the red plot line is humidity over time. And it appears that this is where we set up the CanSat, and it sat around for a while, and it looks like this was probably the event for the CanSat, or the launch period. So let's see what happened here. If this is true, We put this out in the sun, I'm going to guess, and it was a very warm day. This was Manteca Unified launching a rocket. And so it was sitting, that was a very warm day, just sitting in the sun, getting nice and warm inside the airframe of the rocket as it's sitting there waiting to be launched. And then there's a pretty major event here with the change in humidity, big spike. Air got very moist for some reason, and there's a big drop in temperature. I'm going to have a thesis here that says that that's probably the event for the rocket. The rise in altitude giving us cooler air, and with the cooler air, the relative humidity would go up. If you did the ice experiment in class, I think you saw that firsthand how that works. So explore this data further. Let's see what else we can do. We can look at the axes. Let's pick the X, Y, and Z axis. Go ahead and for now, we'll just plot these on the single lines. And let's make this a little larger so we can take a peek at it. And we are looking at some pretty dynamic stuff here. So the x-axis is in blue, the y-axis is in red, and the green axis is z. So with the CanSat, if you recall, the x-axis was really left to right. The z-axis was front to back, and this was sitting inside your rocket, and that was your y-axis. And if you go back and look at the grid here, you can see that there's a massive spike, 8 Gs of acceleration nearly, 7.83 acceleration on the y-axis. This is your rocket event right there. In a matter of just a few seconds, you've jumped to almost 8 Gs of force. Now, why does, looking again at the y-axis, why is it 1 G all along here and then drop to 0? And then it comes up again, and then it drops down, and then it goes up again, and then you have this big spike, and then this looks like the flight data. I looked at this, and I thought, okay, y-axis, that's standing straight up and down, and it was probably just sitting around, getting loaded up or what have you, getting ready. When it got carried, this is the activity here. It was on its side, horizontal to the ground, parallel to the ground in a horizontal position, and that's how it traveled. And then perhaps it got set up here and maybe modified there on the launch rail, maybe make some changes to your rocket, and then the launch event. We can see similar inferences here on these other axes as well. I'd love you to explore those and tell me what you see by looking at graphs. And let's look at pressure as well. One more, real quickly. I'm going to go ahead and select the column, select the row, and this is real ugly, I know, but it's going to get right to the point. For the most part, our barometric pressure is flat, right across the board, 1,007 or so millibars. Nothing really much happening. Suddenly, there's a massive spike downward. That drop in barometric pressure is an increase in altitude. This is your launch event right there, and then it goes down again. So we can blow this up by separating the data and digging in a little deeper. Let me show you how to do that and how to calculate the actual altitude based on pressure. So for now, I'm going to show you a couple quick tricks with Excel. First, in order to do this simplistically, I'm going to insert a couple rows above our descriptors, and I'm going to add a column as well. Insert column, and let's see. With that, I'm going to add min and max, and I'm going to search for minimum values. So formulas in Excel are real simple. If I type equal min and then a parenthesis, and in this case I want B4 colon to be 8025, which is the end of the data. I have done this a couple times, so I know the last bit of data on this particular file is 8025 way down there at the bottom. All right. So that's my minimum for this entire column. If I hit enter, the lowest value for temperature in Celsius during this flight profile was 18.18 degrees Celsius. Now I can take this and replace min with max, and I will find in my data the highest value for temperature being read by humidity. Oops. And paste. And I We need to change this to max. So now I have maximum temperature for this profile was 41 degrees Celsius. That's quite a big delta, more than double. If we look at the profile and look at the data again in the graphs, I think you're going to see this was sitting out on the launch pad, getting heated up by the sun, just getting really, really warm inside the rocket. Okay, so that's how you find minimum and maximum in a column of values. Now, I can actually do this all the way across the board, but here's another little trick that Excel lets us do. I can copy this cell, which is the minimum value for this column, column B, and if I copy it and highlight then all of these corresponding minimum, the minimum row, and paste, it will have replaced the B values to the C values or D values or the E values for each of the columns. So now I have the minimum value for all of my readings as well. If I copy maximum, copy, highlight all these, and paste, I now also have my maximum values. Temperature in Celsius, humidity as a percent, pressure in millibars. Here's another temperature reading from the pressure sensor. There is a discrepancy here on the lowest value. One of those is wrong. I'm going to guess this one because that's pretty cold. This maximum value is similar, so it definitely was getting hot that day. And here's your min and max for your acceleration across your three axes. There's your 7.83 G's in the across the y-axis. So as your rocket went straight up, it suffered the 8 G's, and it looks like your x-axis had a peak of 4 G's of force. So looking back at the x-axis, somewhere during that flight profile, the rocket moved from side to side 4 G's. So if we talk 8 G's of force flying up, reached apogee, this was probably having to do something with the parachute deployment, would be my guess. We can go back and look at the data and see if that pairs up. Maybe something else happened. Maybe someone dropped the rocket. I don't know exactly what happened with this particular flight, but my guess here with the 4 G on the x-axis, that's probably what it was. Y-axis was relatively stable at almost 2 G or minus 1 G of force. Lat and long minimums and maximums really don't help us too much. They will show the outside boundaries of latitude and longitude. So the zero reading means there's an error in our data somewhere. We should not have a zero reading for either of these. But the maximum latitude north, almost 38 degrees, and the lowest latitude west is minus 120. So that kind of sets our bounds. If we remove the zero data, that we'd have to scrub this data to find where there's zero data, remove those, and we get bounds then for our highest values for latitude and our lowest values for longitude. So what is 813 millibars of pressure in altitude? Well, let's find out. Right now, it looks like about 20 degrees or so, 19, 20, 21, 21, 20, 21, 22 degrees Celsius for the launch. So let's just type in 21 degrees here. I'm going to switch over to this calculator online. This is a great little calculator. This was at Mide.com, and this is a little air pressure at altitude calculator. For now, I'm going to just assume pressure at sea level was the mean that you'd expect to find, and we'll set the temperature at, let's say, 22 degrees Celsius. Here is the lowest pressure reading that we received, 813.45 millibars, or 81,345 pascals. And if I calculate, we can see our altitude is about 6,100 feet, which completely makes sense with this rocket. I think this flew on a J415 motor, and that would take us up to more than a mile for sure. So that's how your data looks on checking for barometric pressure. There are so many other things we can dig in here. In just a few brief minutes, I want to show what you could do with the data coming off of your CanSat as you recovered it from your flight, whether it was a high-altitude balloon flight or a high-powered rocket flight. I would love to hear from you guys about the additional things you discovered by looking through this information. If you were fortunate enough to have flown additional instrumentation like luminosity or CO2, I would love to see how altitude might have played a role in that in your data as well. Until next time, fly safe. Talk to you soon. Bye-bye.